So here we have an example of a sequence 4, 5, 6, 7, 3, 7, 9. The first 4 elements are in ascending order. However, the number 3 spoils everything, and our function should be return false because of this. Let's create another file. CheckiO 4.py. What? Yeah, we need to create a function. Let's call it is ascending integers. It's going to be a list of integers. Boolean value. This is what we're supposed to return. So, any idea of what we do? Right. So we need to see whether or not the second is bigger than the first. Well, in terms of Python, actually, we check whether or not the first is greater than the item number 0. Then we need to make sure that the second is greater than the item number 1. The third is greater than the item number 2. N is greater than what? 0, 1, 2, 3, 4. Yeah, integers 1 must be bigger than integers 0. If it's indeed bigger, then we continue, right? If not, it's false, then we return false. Okay, but if it's true, then what do we check? 2 is bigger than 1, right? And again, if it's true, we continue checking. If it's false, we immediately ready to return false result from the function, right? Because one of them are not bigger. 3 is bigger than 2, indeed. And again, if it's true, then we continue. If not, we're ready to return false. And so on. So we must ensure that integers n is always greater than integers n minus 1. Or vice versa, or alternatively, integers n is always smaller than integers n plus 1. Okay, so that's the idea of how we solve it. Let's think about this n thing. What should it do? What do you think will be the initial value of n? 0, makes sense. So can we start from this? N equals 0. While what? Right, while n is smaller than or equals to the amount of integers. How can we calculate the amount of integers? Length of integers, correct. If integers n like that. Okay, we do something here, and you also mentioned else. In case of else, what do we do? So, well, let's see. If this is true, let's return true. Okay. Otherwise, you told me, return false. How can we ensure that it will check all of the integers, not just a single one? N equals n plus 1. Well, but look, if this condition is indeed true, we will not be able to see the next number because we've already returned from the function, from the is ascending function. Our code finishes right here, right on this line. The return true. Okay, let's take this out. Look, initially n is 0, so we compare integers 0 with integers what? Does it make sense to compare the first one with the last one? No, we need to start from the first one and compare it with the second one. And then move this frame. N is 0. How to make 1 from n? But look, if we use the concrete numbers here, they always be constant. So every time we repeat the while loop, they will never change. We will always compare 0 with 1, 0 with 1, 0 with 1. If integers n plus 1 is greater than integers n, right? Look, it totally makes sense. If the next integer, n plus 1 is the next integer, right? If the next integer is greater than the current integer, then we go to the next one. Else we return false. Finally, we just need to find the part, the line, where we need to return true, because we never returned true yet. If you put return true here, then it will stop the function right here, right on the line number 6, without repeating the while loop, without checking the next numbers. It should be out of the while loop, I agree with you, but where? Right after the end of the while loop, right? Like that? Would it work? Mm-hmm. Let's put a valid ascending list. Let's say 4, 5, 6. What should it print now? True. So let's see. Unfortunately, it prints as the index error. The list index is out of range. What does it mean? What is it about? Look, in what line does the error occur? Line 4. What do we do in the line 4? What is highlighted? I totally agree with you. Well, let's test it now. It doesn't work even after the removal of the equal sign. What else can be wrong?